This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're in Unit 7, the section 7.4 if you're comparing to the book. And we're talking about sum and difference formulas. So this video we're going to look at a couple more examples. So for example 1, we want to write the sine of the tan inverse of 1 plus the cosine inverse of x as an algebraic expression. So remember, these two pieces here, these really refer to angles. So a lot of times what I'll do is I'll rewrite this as the sine of theta plus beta, or whatever variables you want to use. And what I'm going to want to do is use my sum formula to expand this. So each of these refers to an angle in a triangle. So for the first one, I know that there's some angle that I've called theta whose tangent is 1. So if the tangent is 1, it's really 1 over 1. So opposite over adjacent is 1. And then if I use the Pythagorean theorem, or if I remember my special right triangles, I know that this has to be root 2. Then I have another triangle over here whose cosine is x, or x over 1. So let's look at another triangle over here. And this is some angle beta. The cosine of beta is x, that's adjacent, over hypotenuse, which is 1. And then I need to find this other side here. I'll just call it y. And I can use Pythagorean theorem again. So I have x squared plus y squared is equal to 1 squared. So y squared is equal to 1 minus x squared, which means that y is equal to the square root of 1 minus x squared. So that's going to be the square root of 1 minus x squared. And now that I have these two triangles, I can find sine, cosine, tangent based on the lengths that I have here. So sine of theta plus beta is going to be sine theta cosine beta plus cosine theta sine beta. So sine of theta, we're coming over to this triangle. The sine is the opposite over the hypotenuse, so that's 1 over root 2. The cosine of beta, coming down to this triangle, it's going to be adjacent over hypotenuse, so x over 1 plus cosine theta, adjacent over hypotenuse, 1 over root 2. And sine of beta, opposite over hypotenuse, so that's going to be the square root of 1 minus x squared over 1. Then we'll just do some simplifying here, multiply across for these fractions. So 1 times x is x, root 2 times 1 is root 2. Over here, 1 times that square root is 1 minus x squared, square root at 1 minus x squared. Root 2 times 1 is root 2. I've already got a common denominator, so I can simply add those. So I'll have x plus square root of 1 minus x squared over root 2. Okay, we have a radical in the denominator, but for these complicated expressions, we'll just leave those. So when we talk about writing an algebraic expression, normally this will involve a variable. Over here, my variable is x. And that's going to be our answer. So again, keep in mind each of these refers to an angle in a triangle. So here's, I just called my angles theta and beta. Work out the two sides of the triangle that you have, find the third side, and then figure out everything else you need. Alright, moving on to example 2. We want to find the exact value of cosine 70 cosine 20 minus sine 70 sine 20. So I'm going to let theta equal 70 degrees, and I'm going to let beta equal 20 degrees, and then I'm going to rewrite this. So I have cosine theta cosine beta minus sine theta sine beta. And if I look back at my sum and difference formulas, I see that this matches with the cosine of theta plus beta. Okay, so in this problem we're kind of going backwards. So instead of expanding the formula to get this and then calculating everything based on this, we're going backwards because I know what theta and beta are. So now this is the same as the cosine theta was 70 and beta was 20. So that's the cosine of 70 plus 20, which is the cosine of 90 degrees. Now, if this was not a special angle, let's say it came out to 86 degrees, we would just leave it as the cosine of 86 degrees. But cosine of 90 is the same as the cosine of pi over 2, and we know that the x-coordinate at pi over 2, it's 0, 1, so it's going to be 0, so the answer to this is just 0. Alright, if you have questions, make sure you write those down and ask me. And let's actually skip down to example 4, and then I'll put example 3 in a separate video because it may be a little longer. Because this is a similar type of problem. We want to find the exact value of this expression, and again I'm going to make some substitutions here to make things a little easier for me. I'm going to let pi over 2 be theta, and I'm going to let 7 pi over 12 equal beta. So now if I substitute theta and beta here, I've got sine of theta cosine beta minus cosine theta sine beta. And I can see that this corresponds to my difference formula for sine, so this is equivalent to sine of theta minus beta. So let's go ahead and substitute theta and beta back in, so that would be pi over 12 minus 7 pi over 12, which gives me sine of negative 6 pi over 12. And again, if this didn't turn out to be a special angle, we would just leave it like this. But this is the sine of negative pi over 2 if you reduce it. So negative pi over 2, it's going to be down here, negative pi over 2. I know my coordinates are 0, negative 1. I'm looking at the y coordinate, so this would be negative 1. Alright, so again, if you have questions, make sure you write those down. Feel free to rewind as needed. And in the next video, we'll go over example 3, and we'll see you there.